So, hi everyone. I'm Arlene.
And I'm Elias Cohen.
And we're from the Dukode studio in Brooklyn, which is a scientific visualization studio, and from MIT International Development Initiative. And that's the end, so we'll start at the beginning. We're going to talk a little bit about a project called OpenIR, and it's really great to come on the heels of Info Amazonia because this is also a very much environmentally concerned project. So I'll give a little bit of the social context, and then Elias, who's the technical lead on this project, will talk about some of the technical case studies. So just thinking about, the past 15 months, 2 years, we've been feeling ecological crises much more severely. Here, where I'm living in Boston, just much more severely locally, but then also when you think about sort of the global context and think about who the people are who are most affected, both abroad, as in the case of Haiti, or almost 10 years ago, the Indian Ocean tsunami, Fukushima, but also locally, Hurricane Katrina. We see, developing communities, even in the New Jersey, New York area affected. So, thinking about what are the resources that we use, whereas a decade ago, mostly we turned to television or, the radio. Now the street maps that we used to use, for instance, MapQuest, now we're using them to track crises because of sort of real-time social data. So here are 3 examples. One is Google's crisis map for Hurricane Sandy. One was a really cool Twitter-curated map called Tweak the Tweet out of the University of Washington. And one is by John O'Keefe's team at WNYC, the sort of predicted surge of Hurricane Sandy. So all of these maps are incredibly useful. Our studio is based in Gowanus in a flood zone area, and so we were using all of these maps. But when it comes to regions that, say, are not as information dense as New York City, the web map systems have varied data. So OpenStreetMaps, which is, most of you know, an open source version of a web map system like Google Maps, is the most widely used mapping system in Jakarta. It's much more reliable than Google Maps or Bing or Yahoo. But when we sort of zoom out of the city, you can see that while the downtown area is very densely mapped, the area just to the east, which is also populated, there's no information. So one way that mappers and geospatial professionals have been dealing with this for decades is by using remote sensing. So here are 2 maps of the same area, and it's difficult to see in projection, but you can sort of see how the true color image, which is what we'll find in, again, our standard web map systems, gives you more information about areas that aren't street mapped or aren't mapped with vector or shape imagery. But just like how when we go to the hospital and we use all kinds of imaging technology, X-rays, MRIs, to learn more about things that we can't see with our naked eyes, infrared satellite imagery assists us in ways that that sort of support true color satellite imagery and street maps. So for the same area, you can see in this infrared satellite image a much stronger color distinction between the downtown Jakarta area and what turn out to be rice paddies and farms to the east of Jakarta. And you can see that very clearly because impervious surfaces are in this more muted yellow, whereas the rice farms and the irrigated areas pop out in blue. So all of this data is, in terms of thinking about sensing, it's collected as part of a large interagency satellite system. This particular data is collected by the Landsat satellite, but it's part of a larger network called the Earth Observation System that's administered by agencies like NASA, European Space Agency, the Japanese Space Agency. And then that system is part of an even larger network, of the sort of sensors that we're thinking about that are closer to the ground. So, we start with, we're talking about satellites, but then this is part of a system that includes airplanes, that includes cell towers, that includes the sort of lower to the ground quadcopters, drones, and ground-based sensor networks that are sort of more the center of a lot of what we're talking about today. But in terms of, seeing this data and standard maps, that's where OpenIR comes in. So our project, sort of the foundational effort is to just increase accessibility and increase the understandability of environmentally sensitive imagery, particularly from these public satellite sources that have been in the public domain for decades, but we just don't really see this kind of imagery all that often. And so our data viewers take band combinations that highlight vegetation, urban impervious surfaces, soil, elevation, and moisture and irrigation very clearly. And basically, we published sets of code, pushed it through GitHub, and so you can build these sorts of data viewers for any given location on the planet. Our initial study areas have been here in New York and then also in Indonesia, which is a really just interesting conflux of economic development, ecological vulnerability in terms of flooding, deforestation, volcanic risk, and worked with a number of different groups, both NGOs, government officials, and also citizen journalism networks, including Aman, which is focused on indigenous advocacy, and also Ruai TV, which is based in West Borneo, and focused on empowering farmers as citizen journalists to sort of track the different kinds of deforestation issues happening in the face of palm oil plantation and deforestation.
So now I'm going to talk a little bit about the kind of the visualization aspects of the project and kind of some data aspects that we are thinking. So this is, so we are thinking about how to combine, I guess, social media as a sensor combined with our satellite images. So this example, the one on the left is a Twitter tracker, and it's tracking flooding. And the interesting thing with this is while there was a storm kind of sweeping the Midwest, we could see kind of the tweets kind of appearing and kind of following the storm. And the other two implementations are, the one on top is an implementation of a risk map, a flooding risk map based on satellite data and a simple algorithm to produce it. Again, combined with social media. And the one below is tracking deforestation through, I guess, crowdsourcing. Another concern that we have is about giving context to the satellite images. So we started thinking there are like libraries, spectrographic libraries that we can use to identify specific materials. So this is a kind of a testing implementation of a spectrographic reader to give context and granularity to the image. So you would click on a pixel and it would give you a spectrographic analysis of this particular pixel and potentially identify what material that is. Another thing that we're concerned is like how do you visualize the rate of change and how do you use this data to quickly identify like rapid changes in the environment. And this is a project that we are working with UNDP. And so we produced two NDVIs, vegetation index images for the Makassar watershed. The one is from '91 and the other one is from 2004. And the big image on the bottom is a differential. So you can see like in the red concentration is really a dam that was built and created this artificial lake. So you can very quickly identify like there was a big like, change that happened in the environment between '91 and 2004. That it's not very clearly visible or easily clearable when you see like two satellite images.
And so thinking about how these kinds of tools are useful in the context of journalism and how, the sort of field of journalism is in the, the large ecosystem of sort of information, resource allocation. One way that we think of OpenIR in the long term is sort of bringing priorities to resource allocation. So if you have, a social map sort of represented by those red dots, sort of Ushahidi-style dots, and in the case of an environmental situation, if you can highlight the areas, that are more environmentally robust and could be good areas of refuge, and sort of highlight the areas that are more environmentally vulnerable, areas that should be prioritized as rescue, then that can help you to, give priority to different kinds of social inputs that you can layer on top. So with that, please do be in touch. We look forward to speaking with you. And as a preview for what we'll be demoing, this is another project that we're working on that is much more focused on biological quantified self-based sensors, implementing that into bike helmets. So we look forward to chatting. Thanks.
Thank you.